the starts of the foundations of matrix arithmetic is to identify when two matrices are equal to each other. So this segment is going to focus on what does it mean for two matrices to be equal to each other, and then if they tie that equality of the two matrices to finding values for our variables to make the matrices equal to each other, how we go about doing that. So here it says, for the equality of matrices, let A be an m by n matrix and B also be an m by n matrix. So right away in the definition, it's telling you that the dimensions of the two matrices that are equal to each other have to be the same for you to even have a chance of equality between the matrices. Then A is equal to B if and only if. So when you have I with two F's in mathematics setting and a definition or theorem or whatever, that means that it goes both ways. So if this is true, then the next thing is also true, or if you have the next thing, then this is true. So it goes both ways. So if and only if the corresponding entries of the matrices are equal. Now, what are corresponding entries? Corresponding entries between two matrices are the ones that are sitting in the same position within the matrix. So first row, first column would be paired up with the first row, first column. First row, second column would be paired up with the first row, second column. So the entries that are in the same relative spot in their matrix are corresponding entries. So how might they ask us to do this? Well, one way is they could just give us matrices with numbers and then ask us if they're equal. So first thing we would do is say the dimension of both of the matrices to make sure the dimensions match. And then we would just go corresponding entry pairs one at a time and make sure that the values in those entries are equal. And that, I mean, once you did one or two of those, you'd be able to just glance at it and see that whether a set of matrices are equal or not. Another thing they can do is have variables in some of the spots and then have you find the values of the variables that would make the two matrices equal. And those are the examples that I have here. So the first example is find x and y such that this matrix on the left is equal to that matrix on the right. So when I look at each of these matrices, I have the one on the left side of the equal sign is a 2 by 3, and on the right side of the equal sign is a 2 by 3. So since both of these are 2 by 3s, they have a chance of being equal. But you also have to have that their corresponding entries are equal. So the expression sitting in the first row, first column of the left matrix has to equal the first row, first column in the matrix on the right side of the equal sign. So this x plus 2y has to equal 7. And then first row, second columns have to match. And if there's no variable there, there's just the numbers there, they have to be the same number. If this would have been a 4 and that would have been a 5, there would have been nothing you could have done with the x and y's that would have made those two matrices equal. So then there are no x's and y's that could make it true. But here, they're both 4s, so that's good. Then first row, third column, they're both 7s. Second row, first column, they're both 9s. Second row, second column, I have that x minus y has to equal y plus 5. And then second row, third column, negative 8 equals negative 8. That's true. So to find the x's and y's, I really just need to solve this system of equations to find the x and y that make it true. Now, solving systems of equations, when it's just two equations and two variables, we can use the methods that we've done in previous material. Like you can solve this system by graphing, by elimination by addition, or by substitution. This one would be really easy to solve by substitution once we get everything a little bit, really easy to solve by elimination by addition. Once we get everything kind of organized with the x's in line, the y's, the equal signs, and the numbers. So the first thing I'm going to do is subtract this y from both sides to get x plus 2y equals 7, and x, subtract the y from both sides, minus 2y is equal to 5. So I have that system. Now in looking at this, the x's are lined up, the y's are lined up, the equal signs and the numbers, and I have coefficients in front of the y's that are opposites. 2 and negative 2 are opposites of each other. So I don't even have to do any multiplication of one or the other equations to get one of the letters to drop out. They'll actually automatically drop out if I add these two equations together the way they are. So when I add these two equations together, I get x plus x is 2x, plus 2y combined with a negative 2y, the y's cancel, so is equal to 5 plus 7 is 12. Divide both sides by 2, I get that x is equal to 6, so that's my x value that makes those two equations equal. And then I still need to find my y value, and I can find it by plugging the x value in either of these two original equations. So let's go ahead and put it in this top one. X is 6, so 6 plus 2y equals 7. Subtract the 6 from both sides. 2y is equal to 1, and then divide both sides by 2. Y is equal to 1/2. So those are your x and y values that make those two matrices equal to each other. So if you put in a 6 for your x and a 1/2 for your y, that would be 6 plus, well, 2 times a half is 1, and 6 plus 1 is 7. So there'd be a 7 here, which would match its corresponding entry. And then if you, in the other spot where there's letters, put in your 6 for your x and your 1/2 for your y, well, 6 minus a half, think of 6 as 12 halves, minus 1/2 is 11 halves, and then plug in your 1/2 for your y here. 1/2 plus 5 will make that 5 into 10 halves, so 1/2 plus 10 halves is 11 halves, so 11 halves would be in both of those spots. So definitely it would make those equal. Let's do that same process on the second example. So it's a 2 by 2 matrix on the left side of the equal sign, a 2 by 2 matrix on the right side of the equal sign. For equality, the dimensions have to match each other, and then corresponding entries have to match. So 7 and 7 are the same. 5 and 2x minus y have to be the same, so I'm going to write 5 is equal to 2x minus y. And the x plus 3y has to be the same as 6. So x plus 3y is equal to 6. And then 9 and 9 are the same. So I just need to solve this system of equations in order to find the x and y that makes these two matrices equal. Looking at this, I'm going to rewrite the first equation where I just pick up the sides and switch them and put them back down. And when I do that, we have 2x minus y equals 5, and x plus 3y is equal to 6. Now again, I can solve this either by graphing, by substitution, or by elimination by addition. When I look at the x's are nicely lined up, the y's and the equal signs and the numbers. And it would be pretty easy to multiply one or both of the equations by a specific number so that when I add the equations together, one of the variables eliminates. So I'm going to do the elimination by addition method. And because I already have opposite signs in front of the y's, I'm going to focus on eliminating the y. So opposites would be like 3 and negative 3, or 5 and negative 5, etc. So since this is a plus 3y, I just need to multiply this top equation by 3, and that would give that coefficient to be a negative 3y, and then those would be opposites and they would eliminate when I combine. So we're going to multiply the top equation by 3. So 3 times, we'll come over here, so 3 times the 2x minus y is equal to 3 times the 5. So that gives me 6x minus 3y is equal to 15. And then I'm going to rewrite the second equation right below it. X plus 3y is equal to 6. And when I add them, 6x plus 1x is 7x. Negative 3y plus 3y is 0. They eliminate. 15 plus 6 is 21. And then divide both sides by 7. I get x is equal to 3. And then once I know that x is equal to 3, then I plug 3 in for x in either of the original equations to solve for y. Let's go ahead and put it in the second equation. So we're going to write x is 3, so 3 plus 3y equals 6. Subtract 3 from both sides, 3y equals 3. Divide both sides by 3, and y is equal to 1. So the values of x and y that make these two matrices equal to each other are x equals 3 and y equal 1. So hopefully you found this video helpful when it asks you to find the values in x and y that would make two matrices equal, or just even knowing about the equality of matrices, what conditions have to be met, and then also how we tell whether two matrices are equal to each other.